Welcome back. Today we're going to talk about microcontrollers, microprocessors, and in particular we're going to focus our study on ARM processors. Let me get started with a couple of generalities. What is important is first to understand the difference between a microprocessor and a microcontroller. So first of all, a microprocessor is a chip device containing processors, and its goal is to handle computational tasks. It is designed to grind numbers, to implement instructions and compute instructions. It typically needs to access memory and peripherals that are not part of the microprocessor. Think about the microprocessors in your personal computers. The microprocessor is implemented on a motherboard that will then distribute and connect this microprocessor to the memory, the DDR SDRAM, as well as the diverse set of peripherals, graphic cards, sound cards, and so on and so forth. The difference between a microprocessor and a microcontroller is that a microcontroller is a chip containing processors as well, but it is designed not only to handle computational tasks, but to handle control and computational tasks. So in order to do that, the chip does include in the same package the processor core, one or more processor cores, the memory system, so the memory element with diverse technologies as well, and a number of peripherals that will be used to communicate with the outside world, sense and control the outside world. So what's inside a microcontroller? So there are a couple of elements, PLL oscillators, voltage regulators. I would say those are utility blocks that are required to make any digital system work correctly. But more importantly, we will have to start with a processor. As I said, a microcontroller does contain a processor. In addition to that, it also contains the memory system. And the memory system is typically composed of diverse set of technology, flash memory to have non-volatile storage to store your programming code, SRAM to store your data, boot ROM to store your init program that you'll use before even being able to program your microcontroller. And it does have a main system bus infrastructure that is used to interconnect those different memory together, provide enough bandwidth between the processor core and your different memory elements. In addition to that, our microcontroller, does have a large set of peripherals. And these peripherals are typically connected using a peripheral bus infrastructure that connect them all. And we can have a various set of functionalities, different communication interfaces, for example, UART, GPIO, SPI, R2C, different time control units, timers, PWMs that are based on timers but are used to interconnect with the external world, watchdog timers that are used to monitor the correct operation of the system, as well as analog peripherals, analog interfaces, real-time clock, and so on and so forth. Very often, those peripherals are connected not directly to the processor because of the different bandwidth requirements between the different set of peripherals and infrastructures, but they're connected to the main system bus through a bus bridge. In the ARM world, that would be an AHB bus, and this is an APB bus. Both buses have different levels of complexity and different bandwidths and different overhead coming from the timing control and flexibility. So when you look at the system I just showed you, we immediately have to consider how to program an embedded system. And people must wonder that things will be very different than what they did on a personal computer. So ask yourself, if you have been doing programming on a computer, you can forget everything about it. Things will be very different because of the following. We have very small memory footprints, only 16 kilobytes of flash, for instance, on our processor. We have simple user interfaces, a few buttons, LEDs, and so on and so forth. no file systems, which is very different. You cannot just load a file and read from a file. You're just accessing directly your memory. You very often have no operating system, or at least only have a low memory footprint real-time operating system that require you to deal with a system per se. And you still need a personal computer to do the software development and compilation. Your system is not capable to compile itself its own code. You will need to design your system on a regular computer, cross-compile it, and load it on your specific target. So things will be very different compared to what you're used to, even though obviously a good experience in programming will help you. In order to master programming of an embedded system, you must understand the architecture very carefully. And it's only when you know the architecture that you will be able to make a good program on that structure. And this is what we're going to review.